Hi everyone, thanks for joining. Just checking if you can hear me fine. Great, thank you, fantastic. So I hope the assignment is going well on your side. You still have some time before you can submit, so today I'm actually gonna cover learning unit 3, and hopefully you've managed to work through that problem I've put up for you. I'll share my screen with you now. Give me a second. Okay, so just let me know once you can see this Excel. I'm just going to make it a bit larger. There we go. Great, great. Okay, so this is the question I actually wanted you to go over. It'll kind of give you a good understanding of the difference between learning unit 2 and learning unit 3. So I will go through it with you. If you haven't, then just pay more attention when I'm going through with you. Feel free to ask any questions if you're uncertain about anything. So this is the question. It is known that the lifespan of a certain make of car battery follows a normal distribution with mean 4 years and a standard deviation of 0.5 years. And you are hired as an independent quality control inspector in this plant, and you draw a random sample of 38 of these batteries. Okay, so the first question says, actually it's one question, but you got to work out both of them in order to determine the answer. So the question is, determine which is greater of the two below. Is it 1, the probability of a battery lasting between 3.8 and 4.25 years, or is it 2, the probability of the mean lifespan of a sample lasting between 3.8 and 4.25? All right, so I'll just make a note of some of the values I'm going to take across because I'm going to use the whiteboard. So I'm just going to keep track of that, right? So if you can look at that question for a bit. So the things I want you to take down is basically it says the lifespan of a car battery, which we will let be X. So X is the lifespan of a car battery. Right, so we'll make a note of that. And then the values in this question, what are the symbols for it? So it says with a mean of 4 years. So that means your mu is 4. Okay, so your mu is 4, and the standard deviation is 0.5. So that's your sigma. Sigma is equal to 0.5. All right, and then we draw a sample of 38. So that's our small n. So you'll make a note of those values. N is your 38. Okay, so make sure you got that down. So X is your lifespan. And just give me a second. I'm going to use my page here. All right, so mu is 4. Sigma is 0.5. Right, your n is 38. Okay, so now we're going to go to the whiteboard. All right, so I'm going to stop sharing. And here's the whiteboard. So remember the notes we made, right? So actually, let me just do penciling. Okay, so our mu, that's our mu, that's equal to 4. Everyone with me? That's your 4. Okay, then we have our sigma, and that is 0.5. And then we have our n finally. All right, so n, small n, which is the sample size, is 38. Okay, so far so good. So they want us to basically answer which of the two is greater. 1, and 1 is this. All right, this is what 1 is. 1 is the probability of, and the values, sorry, let me just go back to that. It was 3.8 and 4.25. Okay, 3.8 3.8 less than x less than 4.25. That is what they want you to work with for 1. Or number 2, if they're asking you something different, they're saying what is the probability of x bar being between these two values? 3.8 less than x bar less than 4.25. Okay, so that's the difference in the questions. All right, so basically, I'm just going to try and neaten this. Sorry, this is x bar. All right, this number 1 is learning unit 2, and number 2 is learning unit 3. Okay, so I just want you to understand the difference. So the thing is, they're saying that you're in a plant and you're measuring the lifespan of a battery. All right, that's what x is. Okay, so if you take a single battery and you try and determine the probability of that battery being between two values or being greater than something, etc. If you're taking a single battery, then you're using 1. But if, however, you take a sample, so you take maybe 20 batteries, and you're interested in what the average of that 20 being greater than something, if you want to look at the probability of that average for that sample, then you'll be dealing with number 2. So do you understand the difference? Just let's get some feedback here. Is it just my side, but you're breaking up lots? I'm not sure, Tina. Can anyone else confirm? Am I breaking up, or I just want to make sure it's mine? Okay, Tina, I think it's your side. Okay. Okay, everyone. So I'll just go back to this, right? So I'm going to explain it again, right? So if we're told that batteries, if we're talking about, like, say, a single unit, follows a normal distribution with this mean and this standard deviation, then if we want to know the probability of a single battery or single of the unit that we're interested in being between certain values or greater than anything, or etc., then we would use x. All right. But if we were talking about the sample mean, so we took a sample instead of just a single battery, so we took, like, let's say 20, and we want to know probabilities of the average of that sample being between certain values, then we talk about x bar. Right? Remember, you must have done this in the previous stats course. X bar is the average for the sample. So is that clear to everyone before I move on? Do you understand when to use 1 or 2? And you understand the difference? Okay, fantastic. Okay, great. So now all we're going to do is we're going to compute 1 and 2, right? And then we'll see which one has the bigger area. Because remember, from the last collab, areas for normal distribution is just basically the areas under the curve. That's the probability. That's the same thing, right? So you will have this in your formula sheet, right? You will have these two conversions to get z. You have z equals, and let me just, I'll have to draw it here, right? So it's, if you had x, it'll be x minus mu all over sigma. And then the other formula, so this is one formula you have, and then the other one is z equals x bar. So you have a formula which deals with x bar instead of x minus mu, and the difference is what's in the bottom. And here it's not just sigma, it's sigma over square root of n, right? You'll come across this formula, and this is to get z when you're dealing with the sample mean. So I'm just going to put a dash there. You can see it. All right, so you'll have these two formulas given to you. You just need to understand when to use which. So for number 1, we're dealing with x. So you would use this formula for 1. Okay, so we'd use 1 for this one. All right, because we're dealing with x. And 2 is dealing with x bar. So then we would use 2, we would use this equation for 2. Apologies, but it's my side, then it's a terrible interference. Sure, no problem, Tina. No problem. Just making sure this thing is recorded. Yeah, it's recorded. Okay. Hope you come right soon. All right, so we know this is how we're going to standardize, and we'll use one of these formulas depending on which whether we're dealing with x or x bar. All right. So from the last collab session, I've showed you how to convert to a z. So let's deal with. I'm just going to deal with 1. Right. We'll do 1 first. Right. So we're going to deal with the top one. Right. So we've got there probability of 3.8 less than x less than 4.25. So we know from the last collab, if you recall, we convert that to a z, right? So if you convert that to a z, we'll have to do to both sides probability. So we'll take 3.8, right? Now remember, for 1, I'm following this equation here. I'm following this one, right? So it's 3.8 on the left side minus mu. Right, I won't put the 4 in yet, even though we know mu is 4, but I'm just going to write the letters all over sigma, right, because I'm using this equation here, right, less than, now it's z, right, less than, now on the right hand side is 4.25, all over, sorry, 4.25 minus mu, all over sigma. All right, now I know what sigma is. Sigma is 0.5, that's why I wrote it down, and mu is 4. So all I need to do is substitute those values into this, and it becomes, if you substitute it into that equation, you should get probability, so the left-hand side, and you can do it if you want. So it'll be 3.8 minus 4, because that's what mu is, and you divide that by sigma, which is 0.5. All right, anyone get a value? Let me see. Minus 0.4, that looks about right. Minus 0.4, excellent. Yeah, minus 0.4. Thank you. And in the right side, what did you get? Anyone? You can do that now. Less than z, less than. The right side will be 4.25 minus mu, which is 4, divided by sigma, which is 0.5. Excellent. Thank you, Danny. Very good. All right, 4.5. So that's what we get for the first question. All right, so this is the first question. Now, you can go into your table and find the probability, okay? You're welcome to do that, but just hold on for a second. I'm going to show you by a diagram how you can actually answer this question without even going to the table. All right, so this is 1, okay? So what we're saying is z between minus 0.4 and 0.5, right? So now let's go and tackle number 2. Let's tackle this one, all right? We're tackling number 2. So now for number 2, we're going to use this equation. All right. So now that will be, so now number 2, I'm just going to draw a line here to separate it. Okay. So that becomes probability. Okay. All right. So it's the same thing, 3.8. So it'll be 3.8. All right. 3.8 minus mu. Right. But remember the difference, because we're using this equation, your denominator is sigma over square root n. Sigma the square root n. All right, and that's how we convert to a z. So this becomes z, and then the right hand side is 4.25. I'm doing the same thing when I did to the left hand side. 4.25 minus mu all over sigma over square root n. All right, because I'm using this equation now, because we're dealing with x bar. And if you enter those values in your calculator, because we know what n is 38. That's the sample size. Sigma is still the same, it's 0.5, and your mu is 4. And I'll do this one for you, but if you want to, you can give it a bash. If you plug all those values in, the left-hand side, it becomes, I'll tell you now, becomes minus 2.5. So it's minus 2.5, minus 2.5, less than z. And then the right-hand side is 3.1. 3.1. 3.1. All right. So the thing is, we are comparing this equation to this one. And that's what we need to compare to determine which one gives you a bigger probability. So remember, this was for 1, this was for 1, and then this one was for 2. All right. Now you can go into your table in the back of the book and work this out, but I'll do the diagram for you and it will make things clearer for you. All right. So what I'm going to do is I'm going to draw this to the best of my ability. So there's our z-axis. Okay, this is our z-axis. This is our z-axis. And then here is our curve. Right, remember the z curve is centered at 0. So the center value is 0 here. Okay, now let's look at the first equation, this one. Let's look at this one here, right? This one says z in between minus 0.4 and 0.5. So minus 0.4 is on the left of 0, so it's somewhere here. Put a mark here. This is minus 0.4. And then 0.5 is on the right of it. So 0.5 is about here. So I'll make it about here. 0.5. Okay, so the first question, number 1, is asking what is the area between these two values. Okay, so what's the area between these two values? So I'll shade it. Let's give it a color. I'll give it a orange color. Okay, it wants this area. Everyone with me? That's what the first question, this number 1, is asking for. So everyone so far with me? Did I lose anyone? I just want to double check here. Thanks, Danny. Thanks, Anya. Okay, great. All right. So that's 1. Okay. Now, if you look at number 2, let's go to number 2. Number 2, I'll go back to red. This is asking for the probability of z being between minus 2.5 and 3.1. So minus 2.5 is much further to the left. It's here. Much further to the left of minus 0.4. So I'll write it. It's here. It's minus 2.5. Okay. And then the right value is 3.1. So it's a very positive value and it's on the other end, somewhere here. It's past 0.5. We can all agree on that. So here, 3.1. Okay. Now the second question is asking for this area, the area between these two values. And you can see this is the red area. Can you see that the red area, okay, between the red area and the orange area, which one is bigger? The red, yes, Sonia, here. Yes, exactly. So you can clearly see that this one has the larger area. So that means this one has the larger probability. So you didn't have to go and look at the table. If you just sketched it, you can tell what the answer is. So the answer is 2. It's the probability of the sample mean, x bar, being between 3.8 and 4.25. That has the bigger probability. Does that make sense, everyone? Fantastic, fantastic. All right, so some things I also want you to take away from this. Okay, so if you look at your formulas for z, look at these 2 equations I wrote down, right? So this is the one and here's the second one. I want you to remember that when you look at the z equations, whatever is in the bottom of the division line, whatever is underneath the division line, that is known as your sampling error. So for our case, when it's just x, the sampling error is sigma. It's the same thing as the standard deviation. However, when it's the sample mean, when it's x bar, then if you look at what's underneath the division line, it's the sigma over square root n, and that is your sampling error. Okay, so whatever is underneath the division line, that is the sampling error. Okay, so remember that and make a note of that for any of your Z formulas. So I'm going to clear this out. Just give me a second. The other formula for Z that you'll come across will be this. So I'll write it in blue. It's Z, and this is when you're dealing with proportions. It is P minus pi all over square root pi into 1 minus pi all over n. Right, all of this is under the square root. This is another formula that's in your formula sheet. So it's the same thing, whatever is underneath the division line, and in this case, it's this entire thing here. So when you're dealing with proportions, this is your standard error. It's this whole thing underneath here, pi into the square root of pi into 1 minus pi all over n. All right, so we'll make a note of that. All right, so I'm going to stop sharing my whiteboard, and I'm going to show you a question. I'm just going to do one more question on the proportions. So if you hold on. Okay, just let me know once you can see this question here. Question 9 says the proportion of students at a college who have GPA higher than 3.5 is 90%. Just give me a thumbs up or if you can see it. Yes, okay, fantastic. Okay, so I'm just gonna do this one here to give you an idea of proportions. Okay, so here, let's read it along, and then I'm gonna ask you something here. The proportion of students at a college who have a GPA higher than 3.5 is 19%, right? You take a repeated random sample of 25 from that college and find the proportion of students who have GPA higher than 3.5 for each sample. What is the mean and the standard error of the sampling distribution for the sample proportions? All right. Okay, so I'm not going to be interested in the mean. The question here I'm interested in is, I want to ask you guys, what is the standard error? So remember what I told you. Whatever is under the Z formula in the division sign, that's your sampling. You have to standard error, so that's your standard error. So here, right? So I'm gonna write down the values. You can write down them for as well. So make a note of that. Your sample size is 25, so your n is 25. Okay, and this, if you look at the first line here, the proportion of students. So here we know we're not dealing with means anymore. We're not dealing with x bar. Here we're dealing with p and pi, the last formula that I showed you. And the 19%, remember pi and p will always be a percent. It will be a proportion. This 19% is what your pi is. So pi is 19%. 19%. Right. And your n is 25. So if I go back to the whiteboard, let me stop sharing that with you. Whiteboard. Okay, so your pi, pi is 19%. Or you can write 0.19, it's the same thing. 0.19. And your n is 25. That's the sample size. What is this proportion measuring, this pi? It's measuring the proportion of people that, students that get a score above 3.5. Okay, that's an American scoring system, GPA. That's not so important. It's just you can just think of it as a percent of people that get a high metric score in a way. All right, so that's how n is 25, your pi is 0.19. Remember the formula for standardizing for proportions is Z, and I'll write it out again. It's P minus pi all over square root, and this is pi into 1 minus pi all over n. All right. So remember what I told you of what the standard error is. The standard error is everything underneath the division sign. So it's this entire thing here in red. So you can compute the standard error. You just substitute the values for pi and n in it. And if you do that, and you can give it a bash, what value do you get for the standard error? I'll give you a second to do it. I can do a poll. What is the standard error? Is it is okay. Rest of you, this is a chance to practice with your calculator. Remember there's a square root as well, so don't forget that. Okay, I'll give you 30 seconds more. Okay, the two of you that answered, you answered correctly. Well done. So that is the standard error. So that's the bottom part. The bottom part, the denominator, that's your standard error, and it's 0.0785. All right, I'll stop this. All right, so now I'm going to ask this question here. So this is the question that's posed to you. All right, I'll write it out. Find the probability of the proportion of students getting score 3.5 being above 20%. Okay, so here's the question. Find the probability of the proportion of students getting a score above 3.5 being above 20%. So this 3.5 is just to mislead you, right? That has nothing to do with what we're trying to work out. The 3.5, you can just think of it as an A. That's what it's trying to say. So if I had to remove this, you can replace it with A. It's saying find the proportion of students that get, find the proportion of students, find the probability of the proportion of students that get an A being above 20%. So if I write it out, we want to know what's the chance of the proportion, right, being more than 20%, right? They're trying to ask us what is the chance of this. So if you're talking about chances, we're talking about probability. Does that make sense, people? P is proportion. It's a small p, not the capital P. What is the probability of the proportion of students who get an A being above 20%? Is that clear? I'm not, make sure I don't confuse you here. I just want to make sure that you understood what I said. And remember, being above 20%, that's greater than. All right, thanks, Danny. And thanks, Sonia. Okay, fantastic. All right, so you want to find this probability. So to convert this P to a Z, we would use this formula. This is the formula you would use. And you can see it. Thanks, Alan. Thank you. You would use this formula here because this formula has that P value. So what we're going to do is we're going to follow this formula here. So now it becomes P, and we're no longer talking about the small p, it becomes a Z. And how we did that is we follow this formula. So whatever we do to the right, we must, sorry, whatever we do to the left, we must do to the right. So this is 20%, right? We are going to subtract pi from it, right? And then we're going to divide it by the standard error. We're going to divide this whole thing here. But we know what this is. We worked it out. We did it in the poll. It is about 0.0785. So I'll write it out. Instead of writing the whole thing out, this is easier. 0.0785. Everyone with me? So this whole thing in red, as we did in the poll, this is the 0.0785. Right? And then we know what pi is. Pi is 0.19. So if I substitute 0.19 into this equation on the right, if I substitute 0.19 or 19%, what do you get? Anyone? 0.12. Yes, yes. Yeah, if you round it, I think it's 0.127. Well, it's fine. We'll do 1 is, yes, greater than 0.127. 0.127. All right, and now we know how to do this. We know how to work these probabilities out from the table. Right now, I'll sketch it for you, and then I want you to find this probability for me. All right, so here's our z-axis. Here's our z-axis, and here's our curve. Right, it's centered at 0. Forgive my line, please. 0.127 is on the right, so it's about here. Remember, just a sketch. So 0.127, so 0.127. And remember, we want the area on the right of this 0.127 or on the left of 0.127. What is that? What do you think? On the right or left? And what would tell you is this inequality sign. So we're looking for the area on the right or on the left of 0.127. Anyone? Okay, so yes, yeah, it's no, okay, so let me explain this. Okay, all right. So we were saying probability of z greater than 0.127. Now remember, this axis, this horizontal axis, that's our z values. So here is where z is 0.127, and the question says z greater than 0.127. So this is the number line. Remember, 0 is here, 0.127 is here. So if you want everything greater than it, then that means everything here on the right of it. That's why the sign is so important. Does that make sense, everyone? So it's the area on the right of it. We want to know the probability of z being greater than it. Okay, great, Danny. Talent, does it make sense? Fantastic. All right. So we want this area. So now, if you guys are pros at it now, so this is your chance. I want you to go to your table, the normal distribution table in the back of your book, and find this area for me. I've got the value. I'm going to give it to you in a poll. So you can work this out now. So probability of z greater than 0.127. I've done a sketch for you. And let me give you, is it, let's see, 6, 5%, is it, Here you go. Okay, so you can like, kind of think of it as like an exam question, and you want to work through it as fast as you can. Okay, you guys still working with it? Do you guys still want time, or do you want the answer? I'll give you, say, 30 seconds more. Okay, good, good. Well done, well done. Okay, for those of you that answered, you answered correctly. Well done. The answer is 44.9%. I'm very happy to see that. Well done, students. Okay, so let me take that out. So if you went to your textbook will give you this area. I'll shade it in blue because the textbook shades it in blue. Your textbook will give you this area here. It only gives you the area from 0 to that Z value. And you would have found, I think this blue area, I think it's around 0.051. Okay, so it's 0.051. But the thing is, you're not interested in the blue area. You want the area on the right of it. You want the orange area. But what you do know is everything on the right, the total area on the right is 0.5, 50%. Because half the area is on the right, and then the other 50% is on the left of 0. So if the total area is 50%, so 50% take away this 5.1% will leave you with 44.9%. And that's what you got. Glad to see it. Well done. That's the answer. Okay, everyone. Hope this made sense to you, today's session. So we covered learning unit 3. You would have, which is sampling distributions. So you would familiarize yourself with this equation here, standardizing when you're doing proportions. So this formula here. And the other formula I did with you earlier is Z equals X bar minus mu all over sigma over square. Sorry everyone, I can't delete the 2. Okay, but just remember this is the second equation. So when you're dealing with averages, you will be dealing with this equation on the right, x bar. When you're dealing with proportions, you're dealing with the equation on the left with p. Whatever is underneath the division line, that is known as your standard error. Okay, everything underneath the division line is a standard error. This is the standard error when you're talking about the sample mean, right? And then this is the standard error, what's underneath the division curve, when we're dealing with proportions. Okay, standard error, both of it is the standard error. That's your key points here. And familiarize yourself with how to find those probabilities, like the example I did now and the one I did earlier. So that's it from my side. Any questions, anyone? Anything you're not clear about? Silence, I'm taking it as everything's good. Okay, no worries, Sonia. I completely understand. And this is great talent. Thank you. This is being recorded, and I'll send the link out probably by tomorrow. All right. If there isn't any questions, and I wish you all well and all the best for the assignment. I think you guys will do well. It looks like it. Okay, you're welcome. Enjoy the evening, everyone.